Well, these are kind of fun problems. I think they're fun because you really have to think. Well, we're using one trigonometric value to find the other trig values. And, you know, I kind of like solving problems. I look at solving a problem as a win. You know, and if you want to have fun, win. And so when I win, I have fun. Now, if I want to win, I got to work. And a lot of times that work involves thinking. Also, when I work, I want to make sure I learn from my mistakes because I make them, as I'm sure you do too. So let's see what we have here. And I've drawn, I've kind of done a little pre-work actually, because you see I've got a graph going on the coordinate plane. And I did it that way because I didn't want to just sketch something out and have a sloppy drawing. But I'm going to encourage you to draw a coordinate plane and start thinking as I'm getting ready to explain. So we're looking to find the remaining 5 trig functions when the secant of theta is equal to the square root of 3. But the tangent of theta, we're told, is less than 0. So I guess one of the things I may want to do, because I am going to use SOHCAHTOA, so I'm going to write SOHCAHTOA up here. And I'm leaving myself a little space because I'm going to write something else up here in a few moments that's pertinent to how we're going to find these. All right, so I want to focus here where the tangent of theta is less than 0. Now, and I know that all students take calculus, all right? And so for the tangent to be less than 0, I've got to either be in the fourth or second quadrant. Fourth or second, I got to be, because if it's in the first quadrant, everything's positive. So, because this is telling me the tangent is going to be less than, it's going to be negative. And in the third quadrant, the tangent is positive. So it can't be there. So I must be somewhere in the second and the fourth quadrant. Now you see I drew this diagram in the fourth quadrant. Now why did I jump to do that? That's because I see that the secant, which is the inverse cosine function, is positive. It's equal to the square root of 3. All right, well, let's go ahead and look at the cosine. I know that the cosine and the secant are, and I'm not going to write theta because it's just, I need a little bit more room. If the secant is the square root of 3, then the cosine is 1 over the square root of 3. But of course, I can't leave that square root of 3 in the denominator, so we're going to rationalize this. And where the cosine now is equal to the square root of 3 over 3. Now, go back to SOHCAHTOA. Well, I know that the cosine is the adjacent over the hypotenuse. I also know that it is the x-coordinate over the radius. All right, and that's why I was able to plot this point right here, because x must equal the square root of 3. So this is the square root of 3. And of course, I'm going to go ahead and draw an imaginary line. I got a right angle. My hypotenuse is my radius, and I know that it equals 3. Now, I've got to find that opposite side to get with my other trig ratios, don't I? I need to, here's theta. So I need to know what this is, which actually is going to be my y-coordinate. Well, if the radius, which equates to the hypotenuse, is 3, and the adjacent side is the square root of 3, I can find this opposite side here by using Pythagorean theorem. So I'm looking for a place where I got some room to work. We'll run out of room. We'll go right here. So then I've got the square root of 3 squared plus, let's say the opposite side, or b squared, equals 3 squared. Well, 3 squared is 9, and the square root of 3 is squared is 3. So then this is going to equal 3 plus b squared. And that's going to equal 9. We subtract 9 from both sides, and we've got b squared is equal to 6. Take the square root of both sides, and b is equal to the square root of 6. So this is the square root of 6. Now I'm ready to think about my sine, because I've got opposite over hypotenuse, don't I? But also, what is the sine function also equal to? It's equal to the y coordinate over the radius. Well, I've already found the y, and this is why I plotted this point right here. This is a little pre-work I did right there. So that equals a y coordinate. When x is the square root of 3, y is equal to the square root of 6. And actually, that measure does actually measure 3. And my radius is always going to have to be positive, right? It's a distance. It's a measure. It can't be negative. All right, well, now I'm ready to rock and roll. So then what is my sine? Well, my sine is going to be the opposite, or the y coordinate, over the hypotenuse, or the radius, and so that's equal to the square root of 6 over 3. Well, what does that mean my cosecant is? Well, my cosecant is going to equal 3 over the square root of 6. It's just the reciprocal of the sine, but once again, I got to rationalize the denominator. So we're going to multiply it by the square root of 6 over 6. This becomes 3 square root of 6 over 6. But I can do a bit more reduction, because 3 will go into 6 2 times. And so my cosecant is the square root of 6 over 2. All right, well, let's see. Now I think I'm ready for my tangent. So my tangent is the opposite over adjacent, or another way to look at it on the coordinate plane, it is y over x. Well, let's see. Let's find our tangent, which is going to be easier. Well, I'll say neither one of them is going to be very easy. Running out of room. Let's see. Let's do the tangent right up here. So then the tangent is going to equal the square root of 6 over the square root of 3. And I need to rationalize that denominator by multiplying by the square root of 3 over the square root of 3. And so that gives me the square root of 18 over 3. But let's see, I could simplify that square root of 18, can I? Because that's 9 times 2 is 18. And the square root of 9 is 3. So I got 3 square root of 2 over 3. And therefore my tangent then is equal to, oh, by the way, critical mistake here. I'm in the 4th quadrant. My sine function, and this is not positive 6. We'll erase this. It's got to be negative 6. Whew, almost a huge mistake. All right, negative 6, because it's in the y coordinates down in the lower part of where it's below the x-axis. And that means my cosecant also is negative 6 over 2. And that's negative 6. That's negative square root of 18. This is negative 3 square root of 3. But I can do a little reduction here. And so my tangent ends up equaling negative square root of 2. I'm glad I caught that. All right, well, now I got to find the cotangent, and I am definitely completely out of room because I got to rationalize that denominator. But my cotangent is going to be the square root of 3 over negative square root of 6. Let's see if I can squeeze it in right here. cotangent square root of 3 over negative square root of 6. And we've got to rationalize the denominator again. So I'm going to rationalize this by negative square root of 6 over negative square root of 6, where my cotangent then is going to equal, you know what I could do is I could do that easier because I solved that thing to negative square root of 2. Let's do that. Let me go back in here. Rather than deal with all this. If the tangent is negative square root of 2, then the cotangent is 1 over negative square root of 2. Let's rationalize the denominator. Negative square root of 2 over negative square root of 2. And this cotangent then is going to equal negative square root of 2 over 2. Yeah, Shazam. All right, let's kind of see what we got here. So my cosine, being in the fourth quarter, is negative square root of 3 over 3. My sine is going to be negative square root of 6 over 3. My cosecant is negative square root of 6 over 2. My tangent ended up being negative square root of 2. And my cotangent ended up being negative square root of 2 over 2. See what I mean? These are kind of fun. I have to think. We're going to do another one. All right, so here I've got the same situation, but now I know the sine is 5 over 7, and the cotangent is going to be greater than 0. Now, if the cotangent has to be greater than 0, what quadrants must it be in? Because the cotangent is the reciprocal of the tangent. So it's either got to be in the first or the third quadrant. But again, looking at this sine right here, it's positive. So I'm going to go ahead and plot this thing in the first quadrant. Now, what is the sine? It is the opposite side over the hypotenuse. Or I could also say it is the y-coordinate over the radius. Well, that would mean that this radius here must equal 7. And my measure from the coordinate here down to the x-axis must be 5. And theta's right here. And I need to find this x-coordinate because cosine is also equal to x over the radius. Tangent is equal to y over x on the coordinate plane. Okay, well, once again, I'm probably going to have to use Pythagorean. I know I got to be in the first quadrant. Why? Because all students take calculus. All my trig functions are positive there in the first quadrant. All right, well, let's use Pythagorean. So then I need to find, let's see, that would be then that 5 squared equals, I'm going to call it plus b squared equals 7 squared, the radius or the hypotenuse. So we got 25 plus b squared equals 49. We're going to subtract 25 from both sides. And what do we got? 34? No, 24. 24. B squared equals 24. Take the square root of both sides. That equals the square root of 24. But I also know that 4 times 6, I'll do it like this. Square root of 4 times 6, well, also equals the square root of 24. Square root of 4 is 2. So my measure of this x-coordinate right here from the origin to the x-coordinate is 2 times the square root of 6. I was hoping I could get away from some square roots. But they did ask to find the exact value. When you see exact value, you're going to leave it in terms of the square root or pi or whatever. You're not going to make an approximation. You're not going to estimate it or round off any decimal. All right, well, now let's get on with my other 5 sines. Well, my cosecant is just going to be simply the reciprocal of the sine function, so it is going to be 7 over 5. Now, what about my cosine? Well, my cosine is going to equal adjacent over hypotenuse, or the x-coordinate over the radius. So it is 2 times the square root of 6 over 7. It's going to be positive. I'm in the first quadrant, so I don't have to worry about that. I'm going to go ahead and do the tangent because it's easy to do too. Now I'm going to have to, I'd have to rationalize it anyway. How about this? I'm going to do the cotangent. Because if the tangent is y over x, the cotangent is going to equal x over y. All right, so the cotangent then, I'm just doing this to save space. The cotangent then is going to equal 2 square root of 6 over 7. I mean, not 7, 5. Y coordinate 5. All right, now I'm ready for the hard part. Let's look at the secant. So the secant is the reciprocal of the cosine, so we start with 7 over 2 times the square root of 6. We got to rationalize. So I got 2 times the square root of 6 over 2 times the square root of 6. And so the secant then is going to equal 14 times the square root of 6 over, well, 2 times 2 is 4, square root of 6. Square root of 6 is 4, so we got 4 over 24. So I got 14 square root of 6 over 24, but both of those are divisible by 2. And so the secant then is equal to 7 times the square root of 6 over 12. Now, what about the tangent? Well, if the cotangent we determined, we figured it because it's a little bit easier, didn't have to rationalize quite as fast. If it's 2 times the square root of 6 over 5, then the tangent is equal to 5 over 2 times the square root of 6. And again, we got to rationalize 2 times the square root of 6, 2 times the square root of 6. And the tangent then is equal to 10 times the square root of 6 over 24 again, because we've already figured what 2 times the square root of 6 is times 2 times the square root of 6. But once again, I can simplify this a little bit, and that's going to end up being 5 over 12. So my tangent then is equal to 5 square root of 6 over 12. All right, looks good. So let's see. We knew our sine. There's our cosecant, 7 over 5. There's our cosine, 2 square root of 6 over 7. Cotangent's 2 square root of 6 over 5. Secant is 7 square root of 6 over 12. And the tangent is 5 square root of 6 over 12. Whew, man, that was fun. If you want to win, work. You want to have fun, work. No, you want to have fun, win. You want to win, work. When you work, learn from your mistakes. And I made a couple in here. No, I usually do. You probably do too. How about that?